shape on the coordinate plane. So, to translate means to slide. All you do is sliding a shape anywhere on the coordinate plane. You're not flipping it, you're not rotating it, you're just sliding it around. And we're going to look at that. To reflect is actually to flip. And you've probably heard these terms before. And we're going to look at reflecting today. We haven't done that one yet. Now, just as a little review, see here we're starting with triangle ABC.
Yes.
I know this is my starting triangle because there's nothing on the letter A. This is what we call the pre-image. And after we do whatever we're going to do to that, we're going to end up with A prime. That little slash mark is how we indicate it's been moved, and it's now A prime. That's going to be the image. That's just a little review. Yeah, you will when I'm done. So I went and got this little thing. Yeah, this is my coordinate plane. It's from next door. Here's my shape. This shape is sitting on the coordinate plane. So I can see there's a point here, and a point here. And I'm going to translate this. I'm going to take and leave that image there, and I'm going to slide it over here. I slid it over. Okay? So now, if I just look, which direction did I go? Did I go in the X direction or did I go in the Y direction?
Yes.
Yeah. My X coordinate here is going to be different than my X coordinate here, isn't it?
Yeah.
Yeah? Is the Y coordinate going to be different than the Y coordinate here? No, I didn't move up and down at all. All I moved was to the right. Okay, so that's a translation. We could also do something like this. Could, if we wanted to, we could move the X. So we could move X, and we could also maybe move Y. That's also a translation. It didn't flip, it didn't rotate. All we did was change the X coordinates and the Y coordinates. Just kind of moved it. See, that's a translation. So let's look at how that would look on here. So here we're saying, okay, you start with the set of points X, Y. We're going to translate them by adding 6 to every single X coordinate that we're looking at and take away 7 from every Y coordinate. This makes it move left and right. This makes it move up and down. X-axis is left and right. Y-axis is up and down, right? Okay? Now, it might make it easier for you to realize that this coordinate plane is a 10 by 10 by 10. Every single one on this paper is 10 by 10 by 10 by 10. So the first thing we have to do is we have this pre-image here. I'm going to write the coordinates of A are -3, 6. I'm going to write those right here. That's the coordinates of point A there on my shape. The coordinates of B are -3, up 3. And the coordinates of C are just over 1, up 3. That's before I do anything to it. Now this rule, we call this a rule. Oh, don't you love that word?
Nope.
I know. So what we're going to do to each of our points is we're going to add 6 to the X, which is going to make it shift to the right. And then we're going to subtract 7 from the Y. Do you think that's going to make it go up or down? Down. It's going to make it go down. So let's just do that. So I'm going to take my X. This is my X coordinate, my Y coordinate. I'm going to take my X, which is -3, and I'm going to add 6 to it to get my new X coordinate. I'm going to take my Y coordinate, which is 6, and subtract 7 from it to get my new Y coordinate. So I have -3 plus 6 is 3. 6 take away 7 is -1. So that's my new A. So let's plot that. So this is telling me that I have to go over 3 and down 1 for my new A. And I'm going to mark that as my new A with A prime. That little slash mark. So let's do the same thing to these next 2 points. My original X was -3. I'm going to add 6 to it. My original y was 3. I'm going to take away 7. I'm going to get 3, negative 4 for b prime. 3, negative 4. So I go over 3 and down 4. 1, 2, 3, 4. Oh, there's my new b prime. All right, and then do the same thing for the last point. My original x coordinate for C was 1, and I got to add 6 to it. Original y was 3, I'm going to take away 7. Yeah, it's going to be 7, negative 4 for my new C. So for every single point, I shift it to the right 6 and down 7. So over 7, down 4. Yeah, and look at that. It looks just like the original. We just shifted it according to the rule that they gave me. Pretty easy.
Yep.
Really?
Yeah.
If you don't even want to like go through all this, you could just say, okay, I got to go over 6. 1, 2, 3, 4, 5, 6. And then I got to go down 7. 1, 2, 3, 4, 5, 6, 7. Oh, there it is.
We don't have to go over it.
Yeah, it depends on what it's asking you to do. It depends on what it's asking you to do.
So no matter what, if it says x plus 6 and y minus 7, and you just go from that point of...
Whichever direction, up or down, left and right. Under translation, the triangles are congruent. Okay? They stay the same size and shape. They just move. All right, so that's kind of what we're going to do for this one. For this one, we have to determine the rule. We have to figure out what this is based on this picture. What happened to A, B, and C? So, which one is my original image? Which one's my original?
One on the top.
No, the one on the bottom, the clear bottom.
How do you decide? Yeah, remember there's no slash on the original, the pre-image. So, here's what you do. All you do is pick one point. Just pick one point. I think it would be easiest to see from B. Let's pick B. And say, okay, from this B to this B, I went to the left 5. So I'm going to draw that. I went to the left 5. I have to take away 5 from my x coordinate. I got to subtract 5. Go to the left. If you went to the right, you would do what? Add 5. And then I got to go up 7, so it's y plus 7. So that's my rule. You only have to do it for one point. It's going to apply for all the other ones. So my rule is x minus 5, y plus 7. What's always first in an ordered pair, x or y? X is always first.
It's 6, isn't it?
Okay? Did I count wrong?
I think so.
7.
As I said, it's y plus 6. Mm-hmm. As I said, it's y plus 6.
What do you go plus?
It's Friday. Okay, so we're not going to do this one because it's pretty much the same. But we have to state a congruent statement. So I'm just going to say triangle ABC is congruent to triangle what?
A, C,
A prime, B prime, C prime. They don't change size and shape, they just slid. Okay, so that's translation. Let's look at reflection now. No, now, let's go back here to our little checkerboard. Okay, so I have this pretty image here. A reflection is like looking in a mirror, right? What you see back at you is really opposite of what you are, believe it or not. So what's going to happen here is I'm going to take this shape and reflect it over the y-axis. I'm going to take it, I'm going to flip it. See how it's one spot away from the axis here? When I flip it, that same point better be one spot away from the x-axis. See that? So this is the same distance. This point here is 3 spots from the y-axis. It better be 3 spots here as well. That's how you do a reflection. Okay? This is reflecting over the y. Could I reflect over the x if I wanted to? Yeah, look, I could do this. If I start here and I reflect over the x-axis, it's going to look like that. Because this is, again, one spot from the x and needs to be one spot from the x down here. That's a reflection. Yeah?
Yeah.
Let's look and see how it looks on here. All right. This is a reflection. Another transformation that results in congruent figures is a reflection. A reflection is a transformation. I know it's kind of saying the same thing twice. That's okay. When we reflect a figure, we map it onto its mirror image over a line. The line is called the line of reflection. It's original. In a reflection, the reflection image is congruent to the original figure. Okay? Now we're going to start here by just kind of flipping this over the line. Now we don't have any coordinate plane or anything. All you do is you just go by each point, A, B, and C. It's the easiest to go by the point and say, this point is about this far from the line, so I'm going to kind of go on the opposite about the same distance. And I'll have B prime. A is about this far from the line, so I'm going to go about the same distance here. It may not be exact, but it's pretty close. And the same thing with point C. It's about that far. I'm going to say it's about that far. So I just kind of went by how far it was from the line and then went to the opposite side. And then connect it. Well, it's pretty dang close. It's a reflection over there. Okay? Under the reflection, the triangles are congruent, or they should be congruent. They may not look exactly congruent. Okay, you could do the same thing with this. Go by the points. Instead of trying to just duplicate the picture, all the vertices there, if you just kind of sort of draw them the same distance from the line of reflection, and then connect them, and then here and here, and then the peak of it, boom. Oh, look at that. That's A prime. Just flip all the points over that line. Again, if you try and do it by the points and then connect them, it usually makes it a little neater. In the coordinate plane, the line of reflection is usually the x-axis or the y-axis. Okay? Usually the x-axis or the y-axis. So, what we're going to do here is we're going to reflect triangle PQR over the y-axis. This is the y-axis. What I need really first to come up with my new points is I'm going to write the coordinates of R, Q, and O. These are, I'll just copy mine here. -7, 9, that's R. I went -7 and up 9. And then -4, 2 for Q, -4 up 2. And then I'm not going anywhere on the x-axis, so it's 0, and I'm going up 5 on the y, 0, 5. Those are my original points. This is pretty nifty. Let's see what happens when we reflect. All right, so R is, I decided it's 7 spots from the y-axis, which means I have to go 7 over here. Oh, look at the coordinates of R prime. They are 7, 9. Oh, the only thing that changed was my x-coordinate. The y stayed the same. Went to its opposite. Let's do Q. I'm going over 4, and then I got to go over 4 here. The new coordinates for Q prime are 4, 2. Look at that, the x-coordinate just changed to its opposite when I flipped over the y-axis. Wait, what's going to happen to P?
Oh,
Nothing.
It stays the same. It's already on the y-axis, so it doesn't go anywhere.
Bro.
So that's P prime also. So it's going to be the same coordinates. Which makes sense because there isn't an opposite of 0, is there?
nope.
No. So we're going to connect those dots. And there we go. Look how nifty that is. All right, ladies and gentlemen, look how they showed this. Now, we did one reflection and we used R prime. Now they're saying, okay, take your original picture and now flip it over the x-axis, but since it's a different reflection, we're going to label the new points R double prime, double prime, double prime. This is a different reflection. So I want you to do that one on your own. Flip this over the x-axis.
Oh, what else?
Hold on a second.
Are we doing the practice?
Yeah, what you're going to do on the back side here is, this doesn't take very long. You're going to do this whole sheet. You don't have to do number 7. I'm just trying to cut down on some time here. You don't have to do number 7.
Thank you.
And you don't have to do on number 9, you don't have to do A, the first A, or the second B. It just kind of cuts down on time a little bit.
You just don't